The second one is where we take the known pathogen genotype to characterise resistance in the host. So at my institute, I have a Rust collection, and Professor Pretorius has one. I think Sajid, you would have one, and some of you in the room may have one. We do our race analysis, we do our pathotype surveys, we find a new pathotype, we characterise it. As I've just shown you, situation one, we characterise the genotype of the pathogen isolate, we define the pathotype, and then we put it into a collection. We've got UG99, TTKSK in our collection. We've got TRTTF in our collection. We have a number of different pathotypes, for example, and then we can use those pathotypes, we can take them out of the collection to test germplasm, the resistance status of which is unknown. All right? So here we have, just to illustrate this point, 4 different pathotypes, the 4 that I just showed you before. In the previous slide, we got 4 samples from the field. We characterised those 4 isolates as being 4 different pathotypes. Here they are again, except now I've shown you what the resistance genes are and what the names of the 3 differential lines are. So Tarsa has LR1, Democrat has LR3, and this genotype Stretton actually has both of those resistance genes. And those 4 pathotypes will give us this pattern of low and high infection types. All right, so we can say that pathotype 1 is avirulent for both LR1 and LR3, right? Low infection type, so it is avirulent on LR1, avirulent on LR3, and of course, when we infect a line with both of those genes, it will be resistant. We'll get a low infection type. Pathotype number 2 is virulent for LR1. We've got a high infection type, avirulent for LR3. Here we are seeing the effect of LR3, that lower infection type of the 2. Pathotype number 3 is avirulent for LR1, virulent for LR3, but here we are seeing the effect of LR1. All right? Pathotype number 4 is virulent for LR1, virulent for LR3, and is of course going to be virulent on both of those genes. So here's our resource. We have these known pathogen isolates, and what we're going to do is use them to try to characterise the resistance in some wheat germplasm that's been sent to me. So I'm working in Australia, somebody here says, well, I've got some wheat varieties and I want to know what leaf rust resistance genes are in them. Can you do that for me? And I'll say, sure, send them to me and I will test them with my known pathogen isolates that I've already defined as being different pathotypes. All right, I know what the virulence and avirulence of these is. So here's the first one of those varieties, let's just call it unknown W. And when we infect that with our 4 pathotypes, we end up seeing a pattern of low, high, low, and high. On the basis of that, we can postulate what resistance gene or genes are present in that unknown wheat genotype. We haven't done a genetic analysis, we haven't crossed it with anything. All we've done is tested it with a series of pathogen isolates and seen the pattern of response. You'll notice that that pattern of response is very similar, or it's the same, sorry, to Tarsa, low, high, low and high. So we would conclude probably that this carries LR1. Now that's not really how we use the gene for gene hypothesis though, okay? It's not the pattern of response. What the crucial thing here is this piece of data here, okay? So this pathotype here we know must carry the avirulence gene for LR3 because we have a low infection type here, right? So pathotype 2 must carry the avirulence gene that corresponds with LR3. That's what the gene for gene hypothesis tells us. And yet, it is virulent on this particular genotype. All right, so this means that it cannot, what we can say with 100% certainty is that this genotype cannot carry LR3. If it did, we'd have the lock and the key, and we would see incompatibility. But we're not seeing incompatibility, we're seeing compatibility. So the way we would interpret this data properly according to the gene for gene hypothesis is we would conclude that this variety does not carry LR3. That would be the proper conclusion from that data. What we would also say is it's possibly LR1, but we can't say that with 100% certainty. All right? Now typically what I do with my tests is I would use about 9 or 10 different pathotypes, And by looking at these patterns of response and using the gene-for-gene hypothesis, I can usually be about 90%, 99% accurate with postulating what gene is present. And I use not only the pattern of the response, and particularly this way of actually ruling out the possibility of particular resistance genes, but I also look at the infection type. And I told you before that the resistance genes have typical infection types. So if a gene typically gives a 0 infection type, and here I'm seeing something like a 2 infection type, I'd say, well, it's probably not going to be that gene, the one that gives a 0. It's going to be one of the genes that gives a 2 infection type. All right, so that allows me to actually postulate. It's not genetic proof, and it's not 100%, but it allows me to postulate the presence of resistance, possible resistance genes. What it does allow me to do with 100% certainty is say that a particular resistance gene is not present. As I said here, I'm able to conclude with 100% certainty that LR3 cannot be in this line because an isolate carrying the matching A virulence gene is giving a high infection type on it. All right, here's another wheat variety that someone sent me, tested with the same pathotypes, and you'll see that the pattern here is very similar to Stretton. All right? So here we would say probably LR1 and LR3. The crucial thing here is that we're seeing a high infection type here and here, low here and here. All right, so we would conclude that this variety probably carries LR1 and LR3. But I stress it's not genetic proof. But we're pretty confident with these postulations. Here's another one, and it is resistant to everything, to all 4 pathotypes. In this particular case, we don't know what it's got. It could have LR1 and LR3 and something else. It might not have LR1 and LR3. It might have another gene that happens to be effective to all 4 pathotypes. All 4 pathotypes may carry an A virulence gene that corresponds to a gene that's present in that unknown wheat genotype Y. In this particular case, here's another one that is susceptible to everything, and on this basis we can say it cannot carry LR1 or LR3 because it is susceptible to some of these pathotypes that carry the matching A virulence gene for LR1 and the matching A virulence gene for LR3. It's susceptible, so it cannot carry LR1 and LR3. Now you might say, oh, well, it doesn't carry any resistance gene at all. It's susceptible. But if I test it with a 5th pathotype, it might be resistant. There might be a resistance gene in that genotype for which all 4 pathotypes are virulent, but a 5th one may be avirulent. We don't know. So it's not right to say this wheat variety does not carry any rust resistance genes just because it's susceptible to everything we've tested it with. There could be another isolate out there that carries an A virulence gene matching an R gene in that variety. But what we can say is that that genotype does not carry the genes LR1 and LR3, or LR3.
So you cannot declare it to be a susceptible line because it's high against all 4. But the point is susceptible to these specific isolates that you sampled.
Mm-hmm. I can give you an example of this, okay? So we have a number of wheat varieties in Australia that are susceptible to all of our stem rust pathotypes that we've tested them with. And yet they are resistant to UG99. You think that doesn't make sense? UG99 is really dangerous. It infects everything. How can you have a wheat variety that is susceptible to all your pathotypes and is resistant to UG99? The reason is they carry a gene called SR28. And one of the unusual things about UG99, all these pathotypes in the lineage of UG99, I think all of them, is that they are avirulent for this gene SR28. That's quite unusual. Most stem rust pathotypes carry virulence for SR28, and certainly in Australia, all our pathotypes are virulent on SR28. We don't see it. So all those varieties are susceptible. We grow them in Kenya and they have a level of resistance. All right, so if somebody sent me those 4 wheat varieties, they said, can you tell me what rust resistance genes are in them, please? I'd be able to give them a fairly good indication of what's not there and what probably is there. What I'd be looking at next is I'd want to know what's in this one here, because it looks like it's got good resistance. It's got resistance that's effective against 4 of our pathotypes. I'd like to know what that resistance is. It might be new, and it might be useful for our wheat breeders to use. But I'd like to know, is it 1 gene? Is it 2 genes? Is it complementary genes? Is it a new resistance gene? Is it one we already know about that we know is effective, like LR9 or LR19? How do we actually do that? That's really important. And what I'm going to do is I'm going to cover that, I think, in the next lecture tomorrow morning, how we would actually go about doing a genetic characterisation of the resistance in that line. All right?